Hello. I just got kind of sad that this was the last one I'm doing of this, but not like that sad. But okay. Anyway, so we are doing computer adaptive testing or CAT this week. So just a couple ways that computer adaptive testing is useful. It's a little bit different than just the classic sequential fixed item testing. And it works because by choosing items in an optimal sequence based on their most useful or informative, the dog also might be a pain in the ass during this, so we're all gonna get through it together. Okay, so items are chosen in an optimal sequence based on the most useful or informative point at the current test, depending on the respondent. So based on their previous responses, as an assumption of ability, the next item that will be given to them is based on that. So a couple advantages are shorter tests, and they can get a good level of ability estimation, reduces risks of fraudulence, or cheating, and then it removes the immediate ability. It provides the immediate ability estimation to the respondent at the end of the test. Okay, so to start, you install cat-r package and library this. I already did this. And the first part is basically setting a baseline for an item bank generation using an IRT model as the framework. So, I switched this. I ended up switching this to a 2PL. So using the 2PL as the specified IRT model, we can generate 500 items. So the bank gen dicho matrix. So I have dichotomous items. I don't have polytomous items. 500 items, and then the model is going to be the 2PL. So next, we're going to signify that item 1 is going to begin with the most informative item at theta ability level of 0. So item 1, 0. And then the next step is going to be to signify the item that's going to be selected after that. So the next item is going to be selected using the Kullback-Leibler divergency criterion. So this is a measure of how one probability distribution is different from another. So it's comparing the true distribution, in quotes, of data against an approximation. And then, so that's the KL. And then the method that is used for this is the Bayes modal method, which is just a sampling algorithm based on given parameters. The next thing we're going to signify is the stopping point. So based on the precision criteria, and then this just means that adaptive administering is going to end at a certain point, and then you can signify the standard error, so 0.3. So you just want to make sure that the ability estimate is smaller than this. So all right, and then the final ability estimator is based on the maximum likelihood estimator, which is something that we use to find the parameter values that give the distribution that maximize the distribution based on the probability of observing data. All right, so next, this will show us the item generation bank from above. It's going to show us just the first row. And since I used the 2PL, you can see the A and B parameters here. If you're using polytomous, you can see the C and D, but since we're just going to be looking at A and B. All right, next we can generate the computer adaptive testing pattern, and we can signify the true ability. So we want theta to be 1, and that the cat options are generated from everything we did above when we generated those 500 items. So the item bank is the bank. Model is null because this isn't a specific type of polygamous one, so the default is 1PL, 2PL. Just threw it in because that came up in dealing with the other models. Start is start above, test, stop, final, all of that. And then next we can run this and we can observe the adaptive test details. So from here, we can see that the cat required 26 items for this one. In my last one, it required 25. But since this is random generation, so that required 26 item responses to reach the specified value, the level of precision from above. And then you can look at your standard error and then your ability estimate. So the standard error is just slightly above that 0.3, and that's just due to some changes in ability estimation that happened during the test, and then the final step that were generated in the test and the final here. And then the final ability estimate is 0.931, which is very close to the theta estimate signified at 1. So that's the underlying ability. Okay. So we can do some post-hoc simulations also to compare. There's also a lot more information I did not cover in here, but you can go across and see the estimates of ability, the different items that were chosen based on the randomization that kind of was coded before. So you get a lot of information from that, but looking at the final results to kind of gather more information. Okay, post-hoc. So you want to simulate new response patterns to compare. So you can use the gen pattern feature, and then you can specify the theta that you're pulling from the item bank, and then model once again is null. And then as we did before, we can compare, but we're going to signify the responses generated from this pattern as opposed to the ones from above. So specifically responses here as X, but the start, test, stop, final are all the same. All right. And then once again, you can observe these adaptive test details. So this one, similar, 25 items for this adaptive test. You can look at the ability estimate was 1.1 as opposed to that 0.93. And then same thing, very close for the the threshold. Sorry. Okay. So when you want to kind of compare these, you can check the different item responses. So the different, compare this against the pattern returned by the cat. And then you can look at these against the item responses generated from that pattern above and then see if they match up. And they do. So you can compare the two different generated responses. Finally, we're going to simulate a set of 20 people, and then we're going to space out their true abilities between -2 and 2, and then we're going to keep everything else in the cat as the same that we have been. So signifying ability level here, and then how many people. And then you can simulate the respondents. This is going to take a little bit of time. Hopefully it doesn't break. And this is why we don't have this happen during the test. But I did read that the Kullback-Leibler was one of the reasons why it took so long to calculate this. There's a different one that you can use that's faster. Oh, my computer sounds like it's about to take flight. Hi. Get down. Yay! Okay. So then you run this and you can view the summary statistics on the whole set as opposed to before we were looking at the different people or the different responses. So you can look at the average length of the test. So we had kind of seen 25 and 26 before. This is 27. Should probably go up to the top. All right. So based on the 2PL, using the selection criterion from the Kullback-Leibler, and then your standard error value of 0.3, so 27.55 items on average to finish the test for those 20 simulated people with all those different ability levels. The theta value is 0.98, very close to 1. And then you can look at the different, so there's 2 simulees for each of the kind of estimate the ability levels. So we signified that point, that -2 to 2, and those are pretty close for ability levels. And then you can see how many items it took them to finish the test, the different standard errors. So once again, really close to that 0.3. And you can compare against each group. So there's 2 people in each group. So you can compare to see that those with the ability level of -0.2 to only took 22.5 to finish, and then you can kind of see how takes more on the ends than in the center. All right, that's all. Goodbye.